All right, excellent. Good morning. My name is Steve Maher. I'm with Risk Management Professionals, and welcome to our webinar this morning. This is part of our ongoing series of RMP and PSM issues. Most of you know that Risk Management Professionals is an RMP PSM consultancy, and we do this as part of our outreach program to emulate best practices, share some of the things that we've learned, and also it helps us internally synchronize on best practices as part of our ongoing training for our own personnel too. Before we get started on the webinar, a little bit of logistics. Most of you are at your desk, but logging into this, we're using a GoToWebinar interface. It does have the ability for two-way communication, but you're on mute so that you can go about your activities, have phone calls, rustle papers, have meetings, whatever. We're not going to be listening to you or broadcasting that. You do have the ability to adjust on your screen. You'll see an image of the speaker. It's probably starting on your left. You can go ahead and move that image around. You can go ahead and resize it to your heart's content. And of course, I'm sure you've got a volume control on your computer. Most people would like to listen to me, but if you really feel like you want to put me on mute or whatever, feel free to. So I guess without further ado, let's get started. The topic for today will be basically focus on damage mechanism reviews, DMRs. This is a new concept that has been addressed recently or has been identified recently, and I'll be identifying a little bit more background in terms of why. And I wanted to share with you how we're addressing that with our clients who allow us to use a streamlined approach currently, and where things might go with respect to detailed DMR assessments and how the detailed assessments can be done as part of an integrated PHA approach. So that'll be our main topic. The primary speakers will be myself, Steve Maher, and also Mike Nour from our office. Even though it says Jordan Scholtz on the screen, Jordan did get called away today for an important client support. He will not be joining us, but joining us for the QA session will be Colin Scholtz. No relation. This name spelling is different, and this is really special because this is a presentation that we'll be giving as for a paper that we wrote for the Global Congress on Process Safety. The 2015 conference is going to be in Austin, and our presentation will be on the 28th of April if anybody's going to be there. So this is special. We're going to be able to do a dry run, or in this particular case, a dry run. This is helpful to us because we'll be able to get some feedback, questions from the audience. If there's things that you'd like to hear more of or less of, look forward to your input as part of the QA session that's coming up. And actually even more special is the fact that Mike Nour, Colin Scholtz, and myself are in one geographic location at the same time. That's actually pretty amazing too. All right, so anyhow, let's get started with the topics. The key thing what we want to do is give some background on the challenge. Why is this an issue? Why is it important to address? And what are the challenges associated with this? What do you want to be doing now? How do you approach it effectively? And pull all this together in terms of making an action plan that will help you out at the facility. So let's talk about the challenge. The key thing that we all have in common is that everybody's operating a facility has to identify potential mechanical integrity vulnerabilities. These things are required right now. There are existing safety management systems. That's what SMS stands for. It's kind of a generic term for PSM, process safety management, and also risk management programs. And the idea is that to enhance what's being done right now to address new regulatory program requirements. There are new requirements coming up. There are existing requirements. How do you make that transition effectively is what we want to share with you, some ideas on how to do that. Just by way of a little background, most of you have been in business for a while, realize that there's a lot of highly hazardous facilities that handle materials that if they're released have a significant potential toxic effect, or they can have a lot of energy associated with a explosion or deflagration. There's a potential for tragedy, and it's also for most of the folks who are listening into this, I suspect you're part of your facility's safety program. So it's one of a core covenant for all of us, whether we're on the consulting side, like risk management professionals, or for people who are actually at the facility. It's a core covenant to try to avoid these kind of tragedies. Well, from these tragedies, a lot of people learn things about safety management systems. We'll focus on the two top arrows for onshore process safety in the U.S. that's driven over the years as a learning process that's now settled into risk management programs and also process safety management as the key requirements. For offshore safety management systems, SEMS is the main program right now, and it's evolved from an earlier version of SEMP and an earlier version of SEMS and API recommended practice 75. All these have kind of evolved together over the years because there's a core set of activities that help address those. Things have changed over the past few years. I'll discuss that in a few minutes. The upper right-hand corner of this slide, I won't go into in too much detail. Risk Management Professionals is actually doing a separate regulatory evolution paper at the GCPS conference, and there's a whole lot going on. We'll talk much more about that in another venue. So all this evolution of PSM, RMP, SEMS, and some of the state programs like CalARP, which is the California Accidental Release Prevention Program, basically revolve around the same elements. And two key elements of those, everybody should be familiar with these, are process hazards analysis and also mechanical integrity. PHA and mechanical integrity have been recognized as core safety management systems elements for many, many years by thousands of professionals as key things that you want to stay on top of. Those sort of things are pivotal events that help control the kind of accidents that have occurred in the past. And those are the two we're going to focus on because both of them feed into damage mechanism reviews. So let's talk about what's been happening over the past few years. Things have changed a bit. There was a fire at the Richmond refinery on August 6th, 2012. Basically, when they started looking at the root causes of that, many of them focused on mechanical integrity and also process hazard analysis, and it made people want to take a fresh look at these elements as well as others. Many agencies got involved and are continuing to get involved right now. Environmental Protection Agency, Interagency Refinery Task Force, that's a group of agencies in California, the California Office of Emergency Services, California OSHA, the Chemical Safety Board, and Federal OSHA are all involved in taking a fresh look at safety management systems programs and potential evolution of some of the requirements of PSM and RMP. There's been a lot, as I mentioned, a pivotal event occurred in 2012. There have been a lot of activities by the agencies to take a fresh look at these programs, PSM, RMP, and related programs, and identify our other elements needed to fortify mechanical integrity and process hazard analysis. At the federal level with EPA and OSHA, they've put out requests for information that identify a number of topics that they're proposing might be beneficial, and they'd like feedback from the public, other agency personnel, and also industry. The Chemical Safety Board has come up with a number of recommendations associated with the Richmond refinery fire that also revolve around mechanical integrity and PHA. Many of those recommendations were endorsed by the California Interagency Refinery Task Force. Then the agencies that are part of the IRTF have worked together on crafting some updates in a proposed regulation that was put out on the 31st of October 2014 for updates to the California OSHA program that deals with process safety management. A lot of activity, a lot of things going on. There's a lot more than we can talk to right here. On April 9th, we'll be doing a webinar on regulatory updates, also through our webinar series. If you want to be signed up for that in advance, go ahead and email producer@rmpcorp.com. We'll also be putting out an announcement for that, and we'll go into a lot of these other programs, where they're going. But for today, we're going to focus on mechanical integrity, PHA issues, and DMR. Damage mechanism reviews. This slide identifies where things are moving based on the Cal OSHA proposed update to PSM regulations in California for California refineries. Basically, it would be a separate PSM requirement applied for California refineries only. It's 5189.1, a separate entity from 5189, which will be PSM as applied to the other California facilities. And I apologize if this sounds really complicated or it's difficult to understand. It is complicated, and there's a lot happening. So there's still an overlap in the middle here in the green area of a lot of the core elements, the things that you're familiar with, process hazard analysis, mechanical integrity, but there's a lot of other elements that are being proposed: management of organizational change, safeguards protection analysis, damage mechanism reviews, hierarchy of hazard control analysis, root cause analysis, etc. All these things are currently proposed as new elements in the October 31st, 2014 draft of the Cal-OSHA PSM requirements for California refineries. I think I got that right. All right, so basically there's still a lot of overlap. California refineries are going to be treated much differently and have a lot of new things to address. So the key thing that I really want to address right now is damage mechanism reviews and what's coming up and what do you want to do now. And by the way, if you're tuned in from outside California and wondering why do I really care about this, well, the fact is that as these things are promulgated in California and applied to California refineries, if one of them is part of your company, for example, if you're one of the major oil companies and you've got a California refinery that's doing this, there's going to be some pressure to want to apply these as best practices elsewhere. And also as the agencies begin to accept these things as best practice and they become more commonplace, there's going to be a gradual pressure to take something that's working elsewhere and proven to be doable and want to do it elsewhere too. So everybody should be keeping a close eye on this, not only refineries outside California, but also other types of facilities in California. These things, over time, they tend to morph and they change, but as best they become adopted as best practices, people are assuming that you're going to be applying them to other highly hazardous facilities. So again, a lot more about that on the April 9th webinar, and also at the Global Congress on Process Safety too. So anyhow, so what are now we're going to focus on damage mechanism reviews. So what are the key requirements and challenges? It basically all came from CSB recommendations to improve the identification of mechanical failure vulnerabilities to address specific root causes from the Richmond refinery fire. The idea and the objective was to minimize failure potential. The mechanism was conducting a damage mechanism review. We'll talk more about what that entails, and basically include mechanical integrity concepts and during the PHA and more closely linking them. As I mentioned before, mechanical integrity and PHA have always been, well, always, at least for the past couple of decades, been requirements of safety management systems. Good practice for PHA and mechanical integrity are to address, during the PHA, mechanical integrity issues, at least at a depth that the PHA team could fathom and deal with, and separately for facilities to have mechanical integrity programs to maintain the containment integrity for its process. So these were always out there. What's identified right now is some perceived vulnerabilities in their application and proposing new regulations to address those. So what's the challenge? Well, trying to make effective use of PHA team resources and minimizing overlap, so you're not doing the same thing multiple times. Let's talk about the specific requirements. The specific requirements, if you, and I'll tell you where to get access to all these updated regulations in a few minutes. In fact, I'm sorry, I already passed that slide. I'm going to go back just a bit. Okay, in your handouts, I'm sorry, Tim, are you able to do this for the audience? Are you able to go back? Okay, great. Okay, at the bottom of this slide, you'll see a web link. We are very actively involved in tracking what's going on with these modernization programs. We keep a web page that we try to keep it as fresh as possible for whenever new regulations are promulgated, and you can go into that page and get links to get copies of all these proposed regulations that are being done, including the October 31st, 2014 Cal-OSHA new PSM requirements. Okay, so let's go back to what are the requirements. In Section K of 5189.1, basically it defines damage mechanisms, the timing for when you do a damage mechanism review, the idea that you're supposed to embark it at the earliest possible time, no later than 3 years after the effective date of the regulation, which you'll hear more about that as on April 9th when we do our webinar, but expect this in the 2016 timeframe. So, and also you're supposed to do it prior to the next scheduled turnaround and prior to the next PHA revalidation at the earliest possible time for those criteria. At a minimum, you're supposed to look at loading failures, wear, corrosion, thermal-related failures, cracking and embrittlement, all the things that you know if you're operating your facility are potential concerns for mechanical integrity. So those are the key things that are identified in the proposed regulation as requirements. So let's talk about what sort of things you can do about it. First of all, there's a lot of existing techniques and things that you're already doing that you're doing in mechanical integrity land and also as process hazards analysis. The idea is, or the challenge, is to try to couple these new requirements into something that already works at your facility that you can build on, you know will function, and you're not going to be reinventing the wheel at your facility or doing work multiple times, or at least try to minimize any sort of overlap. By way of a little bit of background, preventive maintenance has always been a best practice even before contemporary safety management system programs, PSM and RMP. PHA and mechanical integrity were defined elements all along. It's the Richmond refinery fire that made people want to take a fresh look at that. The concerns identified for the August 6, 2012 event is long-term sulfidation corrosion, deficiencies in the metallurgy, maybe some criticism in terms of where the focus of the inspections were, that the sulfidation corrosion mechanism was a known issue, and that there were decisions made in terms of when to fix the problem or to replace the piping segment, and there was some criticism about when those actions were taken. As I mentioned before, several agencies were involved in updating the regulations to address this, and the real focus is on improved hazardous material containment integrity. Piping, vessels, pump casings, flanges, everything that's your containment for your highly hazardous chemical. That's what damage mechanism review is all about. So again, as I mentioned, the idea is what do you do about that? And I'll get back to the first item on this screen in just a minute. Number one, well actually, I'm sorry. You have the option to go about implementing a full damage mechanism review. There's technology out there. There's the ability to do very, very thorough mechanical integrity inspections and also reviews to identify any potential vulnerabilities. You certainly have that option now. The challenge is, of course, is that you don't necessarily have all the guidelines in place that help you do it very effectively. Option 3 on this list is doing nothing. Right now, other than the mechanical integrity and PHA requirements of PSM, RMP, and the state programs, you're really not obligated to do anything about this. You can basically turn your back on it and say, we'll wait for the regulations. In the meantime, we're going to focus on other issues. You certainly have that option based on what we're seeing, what's coming up, and what we feel are reasonable ways of addressing things right now. We do not feel that this is advisable or consistent with best practice. So what we're recommending as an option to address is a streamlined DMR approach, basically taking best practices, the high-value items, to address the objectives of these evolving SMS guidelines. Not only does that fulfill our covenant to try to understand and maximize the degree of safety at the facility, but this also is conducive towards chipping away at things that are going to be later required without losing a lot of efficiency. And we'll talk more about that in a few minutes. Feedback from regulators. When they're looking at this, as you know, regulations usually take a long time to come, but when they get there, they want things done right away. We already know some of the timeline for 5189.1. The concern is, and this is expressed by the regulator, that once that's promulgated, you're not really going to have enough time or resources to really do a good job getting the full gamut of the regulations implemented. What they will recognize is that if you're making progress and you're addressing the high priority items, they're going to allow you to focus on other things and give you some credit for what you're doing, and apply selective grandfathering to practices that you've already applied. This is going to lead into my streamlined DMR approach in a few minutes. Again, the key thing is that when these are promulgated, this is a big item, or potentially a big item. If it's not done carefully and with the right resources, it could turn into a lot of work that's not very well targeted. So let's talk about damage mechanism review approaches in general. There are certain things that are common to all of them, and I'll go through 3 steps that are appropriate for all of them, so you'll know some of the things that you are definitely going to have to do, so there's no way around that. It makes sense to get these started now. Step 1 of any DMR approach is to organize and collect key mechanical integrity program information, define the process portions that you need to apply DMR to, gather relevant information such as process chemistry, process parameters, metallurgy, your PMI identification, your PMI at the plant site, testing and inspection history, what are the inspections revealing, any existing corrosion studies that were done. Most large, highly hazardous facilities have a corrosion control program already that may be closely linked or part of their mechanical integrity program within PSM and RMP. And also as part of those programs, they may create corrosion control documents. So having all this information gathered is going to be necessary regardless of what DMR approach and when you do it. Step 2 is to understand the damage mechanisms. API recommended practice 571 identifies a lot of things that are appropriate for refineries. As I mentioned before, 5189.1 in California is going to initially focus on California refineries. So the initial focal points are already well defined by an API recommended practice. Understanding them and making sure that you're addressing these issues at your plant site is going to be common for any DMR program at any time, and is really already part of mechanical integrity in PSM and RMP and any general duty requirements that you feel may apply to you. Mechanical and metallurgical failure mechanisms, loss of thickness issues like corrosion in the CUI, sulfidation corrosion, of course, chloride stress corrosion cracking, hydrogen embrittlement, other types of corrosion and cracking mechanisms, and also high temperature hydrogen attack. These are well defined in API recommended practice 571, and these are things that are, there's some guidelines, and if you don't understand these, 571 provides a lot of background information to get on top of these items. Step 3 for any DMR program is to really understand the objectives and start working towards that objective. If you don't have an objective, it's kind of hard to reach it. Understanding it and developing a program is of paramount importance. The objective of controlling the hazard and reviewing the gathered information, evaluating it and verifying that the metallurgy and materials are compatible with the process. Equipment's currently fit for service. You really don't have any credible potential for degradation between the times that you're performing inspections and evaluations, and that your testing and inspection program and procedures are adequate. These are things right now that you know you're going to have to do as part of any damage mechanism review and as part of any thorough mechanical integrity program. So now that we've defined all the things that you know are going to be part of DMR, let's look at the options and timing for rollout so you can develop a program at your facility. As I mentioned before, the bottom line here, not the bottom line as in what you want to do, but in terms of the bottom line on the slide, is that you have a choice of doing nothing. There's no specific requirement to do a damage mechanism review at this time. The top line, beginning of full DMR, is also something that the requirements aren't fully defined, and if you aren't sure that it's needed, you may be putting a lot of resources into a program that may be needed somewhere else. So what we're recommending, and coincidentally it's in green, is a streamlined DMR approach. By the way, these columns here, on the left is current. Currently we have HAZOP and mechanical integrity requirements. And I'm going to use the term HAZOP consistently to talk about the type of process hazard analysis that's usually applied at refineries, because it is applied at refineries, and I don't want to confuse that with the PHA regulatory requirement, and a term that I'll be introducing in a few minutes, which is an integrated PHA. So currently you do have requirements for HAZOP and mechanical integrity. Right now you have the option to do nothing, but we're recommending that you start moving in the direction of things that you know you're going to have to do to temper the amount of resources that are needed later and move towards a streamlined DMR approach. Recognizing what's coming up and the fact that Cal-OSHA PSM is scheduled for promulgation in first or second quarter 2016, and of course schedules can change. Also the proposed regulations can change, but right now it looks like it's moving forward to require specific DMR requirements, as I reviewed with you a few slides ago. So what we're recommending is that you move in the direction now of starting to apply things in a streamlined fashion and preparing and organizing your program so it's done efficiently to do an integrated PHA approach, which we'll define shortly, as a way to fully address DMR requirements in the most effective way possible using the things that you've already done for PHA and mechanical integrity elements. So the idea is that you maintain your existing program, you start initiating high-value DMR activities in the form of a streamlined DMR. This is also conducive with best practices and a general duty for making sure that your containment integrity at the plant site is intact. You want to, of course, address high-priority issues from an analysis, inspection, testing, and also any changes that you may make at a plant site. You want to make sure that you initiate the transition of the safety management system HAZOP mechanical integrity programs now to start addressing DMR objectives. And we'll be giving some tips for that shortly. And also keep in mind what the long-term target is, the long-term DMR objectives, and where the regulations are going. Don't be the ostrich on this. You want to be monitoring what these modernization programs are doing with respect to regulations, and truthfully not just for DMR but for all the other things that are currently being proposed for these modernization programs. So a couple of tips on a streamlined approach right now is basically you can infuse, this is something that we do for our clients when they allow us to do this, is to start basically addressing the spirit and context of what DMR requirements now in terms of a streamlined approach. The idea is that we infuse DMR into the HAZOP. We'll get some, of course you need to get some additional expertise. During portions of your team sessions, you'll want to get metallurgical and mechanical integrity experts involved to really help the team out. How we handle this currently is for each high and low pressure or high and low temperature scenario, we look at all the specs for the piping equipment and other equipment to make sure it's compatible with the process conditions and process conditions during an upset. So during a HAZOP study, you're looking at things that cause overpressure events, high temperature events, etc., and of course sometimes low temperature events, and look at brittle fracture issues. But these are kind of things that there's a good opportunity with a little bit extra effort to go and look at material specifications as you're conducting the HAZOP study. Then also for each node, if there are material diagrams available or other corrosion control documents, those are reviewed for each node. Also at the nodal level, we'll execute a little mini checklist to kind of at least challenge the team, are we picking up the big ticket items? And then at the very end of the HAZOP study, as part of a streamlined approach, you can basically apply a more extensive checklist, take a look at the programmatic elements, your mechanical integrity program, how well it's being implemented, and as necessary, it's an opportunity to precipitate recommendations for further review of the program, or if you're not being able to keep up with testing and inspection activities, are things properly prioritized? Do the people who are responsible for implementing the mechanical integrity program have the necessary resources? Most of the big issues and the larger vulnerabilities should come out with a diligent review of DMR issues during a HAZOP as part of the streamlined approach. This is something you can do now. You know it's something that's going to have to get looked at sooner or later, and you know it's the right thing to do. So these are things right now you can do with a very small, fairly small increment on the HAZOP studies and other things that you're doing right now. So where are we at in the presentation? This is really complicated, lots going on. what I've identified is the evolution of the regulatory requirements, where DMR is going, what's likely to be required, and we're talking about what can be done now in terms of a streamlined approach while everything else is being formulated, so that when it is promulgated, you're not caught with insufficient resources to get the job done. So now what I'd like to do is talk about a little bit bigger approach to address the full scope of DMR requirements, and we've coined the term an integrated PHA or an IPHA for that. Basically, the idea is fairly similar to the streamlined approach in that you're doing it during the HAZOP study, but the idea is you're more fully examining DMR elements as part of the HAZOP, thorough documentation, and you're addressing the full extent of what the regulatory requirements are as part of this IPHA approach. And so at this point, I am going to introduce Mike Nour, who's one of our key folks who's on our team here. He's been extensively watching DMR elements. He's going to provide a lot of background in terms of his IPHA approach, and he's going to be doing it in a focused manner this morning, because as soon as he's done, he's going to be hitting the road and running off to a client site. Anyhow, Mike, welcome. I'll let you have this.
Thank you.
That'll help.
Can you hear me all right? Yep. Good. Here we are. Okay. All right. Thank you, Steve. My focus for the slides you'll be looking at, the next 20 or 30 slides, will be on the effective approach to implement a complete damage mechanism review to meet the Cal/OSHA draft regulations, which Steve was mentioning earlier. And we'll be talking about the advantages of this new proposed approach as it is integrated with HAZOP. So a quick outline. We're looking at DMR framework, and we'll get into the 3 steps: preparation, implementation, documentation, and then finish off with a summary and talk about the added value applied. So framework. In 2012, as Steve mentioned, CSB recommended a team approach to hazard analysis of damage mechanism. As a result, Cal/OSHA created the draft regulations, and as part of 5189.1, damage mechanism review is one of the elements as part of that 5189.1. So the combination of the damage mechanism review and HAZOP is what we see as the most efficient and effective way to address the spirit of the draft regulations. And as Steve mentioned earlier, we call this the integrated PHA or IPHA process. So let's get right into it. Preparation. How do we prepare for our damage mechanism review? So before getting into the damage mechanism nodes, I want to give a little background on the basis for HAZOP nodes and how we develop those. So HAZOP nodes, the reason you have them is to normalize large and small units or processes by fragmenting the process into smaller digestible pieces that a team can understand and envision in a consistent manner. And as a facilitator, you're looking to develop a Goldilocks size node. Nodes too large make it difficult for a team to envision and interpret. And nodes too small create too many breaks and create an inefficiency for a team. And facilitators normally call generating nodes more of an art form, and they have more flexible boundary rules, like establishing a single node for every single process chemical, or different phase changes, applying the boundaries at inlet and outlet of major equipment. For example, we see just a quick PFD there. The shell and tube have different nodes there, and the inlet and outlet of different major pieces of equipment are used as node boundaries. So for damage mechanism node development, as contrasted to HAZOP node development, we use preparation team for damage mechanism nodes is what we're proposing, as opposed to HAZOP nodes that only uses the facilitator. For damage mechanism review, we propose process engineer, facilitator, and metallurgist. All 3 of them work together in the preparation step to develop the damage mechanism nodes. And the division rules are a little less flexible and a little more hard and fast. They're focused on 2 major divisions associated with material changes and operating parameter changes. So the first division is when you're sitting down as a facilitator, list out the entire PFD and all the materials that are applied here. And for most refineries or separation processes, you start with a hydrocarbon feed, which is a mixture and separated into products, and different ancillary systems as well as cooling water, glycol, refrigerants, hydrogen, among others. And each one of these should be listed as far as your first division for damage mechanism node development. And this step normally involves a facilitator and the process engineer. Your second division, after looking at each one of your list of materials, you separate based off of operating parameter changes. And the intent here is to say that potentially damage mechanisms are eliminated or increased based off of changes in pressure, flow, temperature. So your thing that you can keep an eye out for, pumps, compressors, heat exchangers, where you'll see differences in those pressure, temperature, and flow. Lastly, you have a mechanical engineer and metallurgist to provide input as far as damage mechanism nodes that might have too many damage mechanisms, might suggest separating that damage mechanism node into a few of them. So your final preparation steps after your full damage mechanism node list is developed is to compile industry literature and use it as a cross-reference. So API RP 571, which is what Steve mentioned a little bit earlier, has a lot of good information as far as the detail as to how damage mechanisms propagate, and quantitative data, like for example here, this is a Nelson curve for HTHA. After compiling industry literature, using industry incidents provides a real perspective for the team and kind of breaks the monotony of hypothetical scenarios as you're proceeding through the damage mechanism review. Lastly, for your preparation section here, if a corrosion study has already been completed, which we know a lot of refineries are doing, the preparation step becomes a lot easier, and your damage mechanism review becomes fuller because you're able to use corrosion loops, and CCDs provide a lot of good information to fuel discussion, as well as site-specific data like wall thickness and integrity operating windows, or IOWs. Okay, let's talk about implementation. Again, we're looking for synergy and the similar analysis technique, and we're very analogous to hazard and operability study method. The defining characteristics of HAZOP are that it's a comprehensive method that utilizes a diverse team of expertise. At the beginning of every HAZOP, we recommend a training presentation to familiarize the team with the method, and we utilize a cyclic approach, which begins with facilitator reviewing the node boundaries, highlighting the PNIDs. Secondly, handing it off to the process engineer to provide a detailed description, including operating parameters and the equipment involved. And then you go guideword by guideword through the HAZOP, and the cycle continues. Once you've completed with that node, the facilitator begins and reviews the node boundaries until the whole process is covered. So for the damage mechanism review, you begin with a node introduction in a very similar fashion. The facilitator begins with reviewing the HAZOP node boundaries using the PNIDs, and then you may have one damage mechanism node or multiple damage mechanism nodes that fall into the HAZOP node. And the idea here is we see a lot of benefit in synchronizing the damage mechanism nodes with the HAZOP node. And instead of passing on to the process engineer to provide detailed description, we recommend passing off the mechanical engineer and metallurgist to provide that description and include the details of the piping and equipment metallurgy, as well as operating parameters and other contributing factors to the damage mechanisms in question. Okay, so as far as implementation, our proposed method includes a worksheet that's analogous to HAZOP as well. And what you'd classically see in a HAZOP as a deviation column, we have as the DM node, which includes a short description and the operating parameters involved. Within each DM node, you have different causes, or the way we title them, damage mechanisms. Each one of those damage mechanisms should be looked at from a consequence perspective, and the consequence will follow exactly the same defining characteristics as you would in a HAZOP, which is number one, full description of the ultimate potential consequence, two, a global analysis looking at any effects upstream and downstream, and then lastly, omission of safeguards. Now, what we see as one of the big benefits of doing a damage mechanism review would be to add the added sequence detail. accident sequence detail, excuse me. There, in a lot of HAZOPs that we see, the focus would be to get to the ultimate potential consequence, but not focus on the detail with which damage mechanisms propagate. And that's our main recommendation here for a difference in the way consequence should be developed. Second defining feature for the damage mechanism review as contrasted to HAZOPs are safeguard categorization. So classically for HAZOPs, the focus of safeguards are the non-inherent safeguards that you'll see there, like process controls, process alarms, and shutdowns. The proposed method includes a categorization of inherent versus non-inherent, with the inherent safeguards being associated with piping metallurgy and injected chemical, looking at them from a perspective of something that can fail in the DMR, whereas in the HAZOP, you might assume that piping or metallurgy does not fail. Secondly, for safeguard development, we also want to focus on mechanical integrity depth. A lot of times in HAZOPs, we see that mechanical integrity is acknowledged, and it's said that, okay, well, we do PMs or we do mechanical integrity on a routine basis. But the idea here for the damage mechanism review is to go into a lot more depth on mechanical integrity, ask about the frequency, challenge the effectiveness of the PMs being applied, and how operational observation sees the piping and the metallurgy involved. As far as risk ranking is concerned, the name of the game here is synchronization. We want to keep it exactly the same as the HAZOP. Keep the IPHA, keep one risk ranking matrix for the entire IPHA. And this provides two major advantages. Number one, you have consistency, like I said, throughout the IPHA. And in the inevitable scenario where you have a divisive team that's stuck between two severities or two likelihoods, allowing the team to calibrate with the process HAZOP would provide you potential to converge in your damage mechanism review, as it is a new method. And secondly, from a managerial perspective, for action item prioritization, having two different risk ranking matrices would make it a little bit difficult to establish a level playing field for action item prioritization, but keeping it as one would level that playing field, make it a lot easier to prioritize them. As far as recommendations are concerned, the way we envision the damage mechanism review to proceed is to have the recommendations centered around mechanical integrity. For your high priority recommendations, looking at upgrading metallurgy or potentially doing an inspection during an unplanned shutdown and turnaround. Your low priority would be a high level inspection, maybe just waiting for a shutdown or turnaround or a convenient time to do an inspection to see if everything's up to snuff. So here's our sample scenarios. You'll notice it's very similar to a HAZOP worksheet, right? So as I mentioned earlier, you have your DM node and your deviation column, which includes a quick description and the operating parameters, and then your damage mechanism is included as the cause. The consequence includes a lot of detail, even including operating parameters and direct verbiage from API RP 571, and you'll see that the safeguards there are categorized. And we use different colors. We use blue for inherent and red for non-inherent to really separate and to make sure that categorization is shown. You'll see that the risk ranking matrix looks very similar to a standard HAZOP one, as we described earlier. And the comments is used to reference the reference material that was used to develop the full scenario here. For documentation, as you saw, the worksheets, we want to maintain a relative consistency, and that consistency will provide synergy among the report, the worksheets, and again, for IPHA action items. The IPHA, as HAZOP was, is primarily a reference tool, and having a common worksheet and common documentation style will only create ease of reference later on. So here's our general approach as far as a recap. We define the DM node, identify and bin credible damage scenarios, identify potential consequences, and evaluate the next damage mechanism within the loop, and then evaluate the next loop as the loop continues there. So here's our conclusion to see what the added value is just for the DMR section here. Steve's got another conclusion on the entire presentation. But for just my section here, what we're seeing as a little extra preparation and using a similar analysis technique makes for a seamless integration with what you're already doing in HAZOP studies and through the IPHA. The increased information available during the session and industry literature will fuel increased discussion, and added team expertise through your mechanical engineer and metallurgist will ensure that you have robust scenario development. And then defining features, increased value of the review by considering inherent aspects as safeguards, the ones that you wouldn't classically consider safeguards in a HAZOP, but through a damage mechanism review, provide the maintenance team or the reliability team an avenue of challenging and using the DMR as a reference tool. And lastly, the risk ranking consistency creates an overall alignment among all steps in the IPHA. Steve?
All right. Mike, thank you. Tim? Audio okay? Okay, great. Oh, by the way, in about 5 minutes, you'll have the opportunity. We'll be going into a question-answer session. Our producer, Tim Lee, will be delighted to take any questions that you have and go ahead and present them to the speakers and also our special support person, Colin Scholtz. And so we'll be able to address any. Well, hopefully we'll at least address any questions that you have. You know, I also should have mentioned earlier too that if there's any problems that you're having or you do have issues that come up during the discussion, please feel free to use the chat window to communicate directly to our producer, Tim Lee. Okay, so just to summarize a little bit, PHA, process hazard analysis and mechanical integrity, are already part of every major safety management system program in the United States, onshore with PSM and RMP, and the state programs like CalARP, and offshore with SEMS. They're fundamental elements. Everybody knows how important they are with respect to maintaining or minimizing the potential for accidents at your plant site. One could also even argue, or at least it's arguable, whether or not they already cover a lot of the things that need to be done as part of damage mechanism reviews. Irregardless, DMRs are coming up in some form or the other, and they're precipitated by perceived weaknesses or vulnerabilities or things that people aren't doing when they implement their PHA and MI programs. So when you're rolling this out and you're looking at addressing damage mechanism reviews, keep sight on the long-term objectives. Well, two things to keep sight of: long-term objectives, and also most of the stuff you're already doing. You're already doing it as part of your PHA and mechanical integrity programs. It's a matter of buffering the programs, beefing them up if you need to, repackaging them a little bit to make sure you're going to fulfill any of the new requirements. Again, you at the plant sites are doing most of these things already as part of your safety management system programs. So as DMR rolls out, the best choices that we can offer are to begin right now applying a streamlined approach that addresses the spirit and essence of what DMR is all about. And then when DMR is required and comes about formally by regulation, use an integrated PHA or an IPHA approach to efficiently address DMR requirements. Again, this synchronized IPH approach, it works with existing programs. It addresses best practices, addresses potential upcoming requirements, and it's very efficient. So when you're looking at IPH, when you're looking at the rollout of DMR, again, to re-emphasize the importance and efficiency associated with integrating these two elements, you do have the option, the option at the top of doing a separate PHA and DMR. You can do them separately. They're going to be separate elements, or at least currently in the proposed regulations, they're separate elements as part of 5189.1, the proposed Cal-OSHA PSM requirements for California refineries. However, doing them together as part of an integrated PHA, our experience and what we've seen so far is that it can be quite a bit more efficient, and if you do this as part of the IPHA approach. Okay, there's a lot of good reasons to get started now. Even though these are new regulatory elements, they're really part of existing PHA and MI requirements, and there are general duty clauses and requirements out there to be applying best practices and to make sure your programs are intact and fulfilling the essence of process safety. The integrated PHA approach does provide, it uses elements that you're already implementing. So you don't have to develop a new program, a new framework for just to address DMR. You're going to be using elements that are familiar. People can facilitate it properly. You're not going to have to use new software. You're going to make good use of team resources. And basically, when you're doing the MOC program, it integrates with these things that you've already integrated as part of MOC. So you're going to have a single document to address your IPHA can be a single document to address PHA, MI requirements, and the new DMR requirements. So, and there's a lot more you can do with this. When you start integrating it, as I mentioned before, it facilitates the definition of safety integrity levels, prioritizing safeguards, and helping feed into your mechanical integrity program testing and inspections. Is everything working okay, guys? Yep. Okay, great. All right, well, in that case, we're going to move right over to our question and answer session. I'm going to invite Colin Scholtz and Mike Nour to join me, and then Tim Lee, our producer, can go ahead and toss any questions over. Sure. And actually, I don't know how big the camera frame is. Tim can tell us if we're need to be cozier or not. Is this better?
How about now?
All right.
Great. Just press the mute button.
The first question here we have is the focus at this time only at the refinery level or any California RMP PSM facility?
Okay. May I start? Sure. All right. Yeah, currently the focus of mechanical integrity and PHA is for all CalARP. In California, it's the California Accidental Release Prevention Program, all CalARP facilities, RMP, and PSM facilities. However, for the new requirements and the proposed regulations by Cal OSHA that are coming from CSB regulations and this Interagency Refinery Task Force are focused on California refineries at this time.
Would you recommend that companies begin implementing a high-level DMR as part of general HAZOP procedures?
So yes, as part of the draft regulations, if what we're recommending for facilities that want to get a head start on damage mechanism reviews, it would be a great time to implement it and infuse it with the HAZOP for the IPHA that we recommended there.
Yeah, I'll also build on that. One of the challenges, and we're going to discuss this more in our April 9th regulatory webinar when we're going to identify these, talk about these modernization programs a little bit more, is the intense training requirements that are going to be needed for not only industry but also the regulatory personnel too. In California, there are 97 Certified Unified Program Agencies, or CUPAs, that administer the state program, as well as oversight by Cal OSHA, federal EPA, and a number of other agencies that get involved in slices of what PSM and RMP are all about. Everybody's going to be struggling with getting on top of this initially. So by moving forward with a high level approach or a streamlined approach of getting this done, you're really going to be chipping away at this. You're going to make progress, and it's going to be perceived as very favorable to the regulator. And if you get a good fraction of that done, they're probably going to grandfather you and allow you extra time to do any final touch-ups on that while you focus your program on something else. Colin, did you want to add to that?
Yeah, Tim, am I coming through?
We kind of do this.
Is my audio coming through? Okay, yeah. Just one thing to add on to both of those is that the PHA, the fact that PHA revalidations have to look at MOCs within the past 5 years and incident investigations for the past 5 years. Hypothetically, when you do an MOC, you should be checking the hazards and doing a mini PHA if it's a big enough change. And so when you do your revalidation PHA and you look back at those MOCs, it's really just a check, if you will, to make sure that original MOC covered any additional hazards that were introduced. This is kind of similar. The mechanical integrity program, a robust mechanical integrity program should be addressing a lot of these things. And so the DMR is a way to kind of bring that back into the PHA, similar to reviewing MOCs and incident investigations.
Okay, thank you.
Would the risk ranking criteria for DMRs be slightly different than those used for PHAs associated with the inherent and non-inherent safeguards?
So the intent of aligning the risk ranking matrix was to ensure that the IPA was fully aligned. The inherent and non-inherent safeguards should not affect the way that a risk ranking is developed, or any likelihood ranking, the way the team should be seeing it. So I guess the answer is really no there, but as far as our proposed DMR methodology.
I'll build on that a little bit too. A lot of you have to deal with layer protection analysis and also defining SIL levels for your safety instrumented systems. By doing an IPHA approach, it basically puts everything together, so the team is having some consistency in how they address consequences. They can put in various factors to address likelihood of mechanical failures, and if you have other active safeguards that are safety instrumented systems coming into play, you've got a uniform approach for that, so you're not missing something radical or overrating your SIS.
What personnel are required to make up the DMR team?
So at the minimum, we want operations, process engineering, facilitation, and a metallurgist and mechanical engineer.
Could you please explain the need to separate out the inherent safeguards?
Sure. So it's not a need. It's more just an idea to really add value through the damage mechanism review. The inherent safeguards we saw as a contrast to the way HAZOP normally looks at corrosion damage mechanisms. For the damage mechanism review, we saw inherent safeguards allow a mechanical integrity or a reliability team afterwards, when referencing the damage mechanism review, to get some added value and to see, to look at the piping metallurgy, for example, as something that could fail, whereas classically in HAZOP, that's something that is not considered as a safeguard that could fail, similar to the non-inherent safeguards.
I'll build on that too. It's a way also to help discipline with the team. So they're clearly thinking of what kind of safeguards they're applying and what kind of credit they're getting. If you look at the way people, that a lot of, let me be blunt, a lot of sloppy HAZOP studies were done in the past, they'd put in a whole bunch of items that were basically inherent design features in the safeguards column, and they really didn't help the team kind of sort through the things that needed to come into play during an accident sequence versus things that were inherent in the design. In fact, I've picked up HAZOP studies that were done by others where they basically list out safeguards that basically show you that the event can occur. So these kind of things are these kind of ways that we are proposing here with respect to using inherent safeguards are ways to apply discipline so the team can clearly understand what safeguards are effective.
How much extra time can a person expect is required to complete the IPHA approach versus just a plain PHA? Percentage value would be appreciated.
I was thinking about that last night too. I think in general, I'm gonna let Colin and Mike talk about this too, or disagree. My expectation is around 30%.
Yeah, and I think a company that has a very good mechanical integrity program, it will not be as painful, if you will, because a lot of this stuff isn't new. People have known about damage mechanisms for a long time. The first edition of API 571 came out in 2003, and I know that there are metallurgist failure handbooks that have been around since at least the 70s, probably earlier. And so the point I'd like to make is that the companies with a good MI program should already be tracking their failure data. If they have pinhole leaks, they should be tracking that information and identifying what the causes are. And so if you have all that data ahead of time in an organized fashion, ready to present to the PHA team, it would make the transition a lot more smooth.
Would a metallurgist have to be present or is a design engineer adequate?
Okay, well, I think it depends on the people, like anything else. In a lot of cases, what you can do, and it depends on the process, how significant the corrosion mechanisms are. There are a lot of processes where basic carbon steel are just fine for the majority of it. So what you can do in those cases is rely on if it's a good design or process engineer who's tuned into metallurgy, and if you got great P&IDs that have the piping specs and everything else on it, and you know the mechanical integrity program is verified through a PMI program, the specs are okay. You know, there's a whole lot of variables here. But if you've got a good team, a good process engineer, good process safety information, in a lot of cases you can do most of this without the metallurgist being there all the time, and have them involved in your overview discussions of the program, and to come in periodically for questions, to verify results, etc. Like anything else for a HAZOP study, it's highly dependent on the personnel at the table and the quality of the design information.
The original title for the webinar mentioned SPA and HCA. What are they and why weren't they discussed this morning?
All right, that's a good question. The regulatory evolution has a whole lot of different elements that I reviewed in one of the earlier slides that are currently being proposed as part of the Cal-OSHA PSM requirements for California refineries. And these include a lot of other elements. You saw management organizational change. The SPA is a safeguard protection analysis. What that is a validation that safeguards are appropriately effective. A lot of that is accomplished by a good, thorough LOPA that's coupled with the HAZOP study. HCA is a hierarchy of hazard control analysis. Most of you would recognize that as part of an inherently safer systems evaluation, or at least that being a core part of that. These are other elements that are required. They are potentially significant impacts on your program in terms of things that you have to do and evaluate at your facility, and we needed to focus on DMR for this particular presentation. We will be discussing HCA and SPA a bit more in our April 9th webinar when we look at these regulatory modernization programs.
That's it for questions.
Colin, anything else? Mike? All right, anyhow, thank you for attending. If you do have any other questions, please feel free to email us or give us a call. Oh, good. The phone number is right on the screen, and our email addresses are on the screen, and they're part of your presentation handouts. Again, these are tough issues. It's a moving target. If you do have questions, call us. Thank you.